talking about their angles.
Yeah.
What about their angles though?
They have to be congruent.
Congruent angles, and what about their sides?
Had to be
No. Starts with a P.
perpendicular.
Yeah, they're proportional. So today, instead of having to check every little thing, we're going to learn our first shortcut, which is angle similarity. So what do you suppose needs to be true? Anyone again?
Are you giving us new chapters here?
Yes, coming tomorrow.
I don't, let me be honest, buddy, I don't know where my paperwork is. Put it in.
Our first shortcut is angle similarity. And you just see two angles in corresponding spots, congruent, and then that's enough info. To say our triangles are similar. Super easy peasy.
I found it, buddy.
Did you?
A little far.
You got excited.
Yeah, I went a
You
little
just
far.
got excited. So we just need to determine if these two triangles have two angles that are the same. So do we know anything? What do we know? E is equal to F. Oh, why is D equal to F?
Because they're parallel.
Alternate here because the lines are parallel, yep.
And then the two angles, two vertical.
And then don't forget vertical angles. Yep.
And that means that's similar.
They are similar because I have two pairs of angles that are congruent, so
This page might.
yes. They are similar. And then we need to write a similarity statement. So if I said triangle BEC, you would say it's similar to what? What matches D? F. What matches E? E. G. Done. Not so bad, right? Pretty easy. We're just looking for angles today. Okay. Our next one here.
I don't like these
Why? Yeah, can we find what B is?
ones. Oh, it's always been wrong. I thought it was the one like yesterday. I had to like
No.
get the ratio. to see.
Yep, so subtract from 180 to find B. Come and tell me what you get. Is it 63?
Wouldn't have to be because. Wait, no, never mind.
Because they might try to trick you.
No, only if those two equal each other.
Yeah, right. Morgan, what did you get, my dear? 79? Anyone else want to confirm 79?
Not 58.
I got
58. There's so many different.
I don't think it's
68.
68?
Yeah,
Do
68.
I need to do this myself?
I got it. 180 minus 58.
How many kids does it take to subtract from 180? Everybody.
I think
That's how you set it up.
Yeah, he said 79.
58?
It's two evens. You're not. How do you even get?
So, do we have enough information? Should we find E just for fun? You guys find what E is?
121.
And then subtract 63 more?
68 equals 63 to 100.
Oh, 131. So 180 minus
49.
49.
Good job, guys.
So do we have two pairs of congruent angles?
No.
Not similar.
No.
A hard no.
There we go. Go on page in.
Good job.
That page.
Well, notes are going to take literally like 3 more minutes, and then you have an assignment, yeah, but you'll get that in time. Yeah. That was awesome.
Thanks, Noah. Thanks, everyone.
Do you guys see our two triangles here? See how the smaller one's embedded in the big one? Round table. Thank you.
Vanish.
So let's first find this missing angle in the blue triangle. So subtract from 180. What do we get?
22.
22? Well, I want to find M.
Oh.
How am I going to find the measured angle M?
180 minus 25 minus 66.
Yeah, Yeah, right? That's an angle, and that's an angle, so subtract those from 180. 180 minus 25 minus 67. 88?
Use -3. Or plus 3.
So if we look at our two triangles, we have two pairs of congruent angles.
Yeah.
No.
No, 25 doesn't match 22. 88 doesn't match 91, so
But they would have to match.
it'd have to be the same. Have to be the same. So this is another. No, not similar.
Easier.
Just want to test. I said chance
No.
Do you guys see the two triangles here?
Yes.
Sometimes it helps if we go like this. There's our small one. Here's our big one. Okay, do we have any angles that are the same that we know of?
M and Q are quarter or corresponding.
You guys see how L's in both, right? Okay. And what'd you say, Vlad?
M and Q are corresponding.
Yep, right here and right here.
N and Q are corresponding.
So would this be enough information?
Yeah.
So if we did the small guy first, triangle LQP is similar to LMN.
Thank you.
Done. The triangles are similar. Find each measure. So we're going to set up a proportion like we did yesterday to find out a missing measure. So again, we have the small guy and the big triangle. So what does 3 match? 5. So 3 over 5 is equal to, what does 12 match? What would match this side of the big one? X. Perfect. And now we just solve. Yep, 3x equals 60, cross multiply. X equals 20, is that what we want to find? Yep, yes, perfect. Find xz. So what's the proportion I can write on this one?
5 is equal to 4.
So this 5 matches which one? 4, yep. Equals y over 5.
Why can't it? Is it angle?
Give you the matching angles, yeah. It's all just a matching game, folks.
It seems kind of obvious.
Does it?
What is the other angle? Do we know what the other angle is?
No.
Because I feel like that one's also.
4.5.
We have something to do.
Or sorry.
6.25, right? Then our last one. So the cell phone tower casts a 100-foot shadow. At the same time, a 4-foot, 6-inch post near the tower casts a shadow of 3 feet, 4 inches. Find the length of, or find the height of the tower.
Never. I would never.
We have to set up a proportion. We can do the height over its shadow. That, I think, would be an easy thing to do. So if we start with the phone tower, do I know what the phone tower's height is?
Nope.
No.
So we're going to call that X. But what's its shadow? 100 is equal to, what is the height? Because this is a proportion.
4.5.
The height of our, what was it, a post?
4.5.
4.5. So how can I write that?
4.5.
4.5. You want to use decimals? Is that okay?
No, it's use fraction.
And then what would our shadow be?
3.3.
I was at 4.5.
So 4 feet 6 inches.
Oh yeah.
How many inches are in a foot?
6.
12.
12. So 6 over 12 would be half, right? Does that make sense? Okay. But then how are we going to change 3 feet 4 inches into a decimal?
3.25. Or,
So
yeah,
4 over 12.
3.3.
What does 4 over 12 reduce to?
1/3.
1/3.
Fractions of 3.33.
So 3 point, yeah. Over 3 point. And now what do we do? Cross multiply. X. Everyone divided by 3 and 135. 135. Does that seem?
This is
135.
135. Anyone know how tall a cell phone tower is supposed to be?
yeah, it's like 125.
I'm still wrong. 35 or 25?
No. That's not how it's supposed to be.
Could you Google it?
No, I'm just taking.
Oh, I'll Google it. We'll see how accurate this problem is. Okay, you should look and see if the assignment does match what we did in our notes, because my book was really weird and wasn't really matching yours, so I tried to use yours online, but I don't know if that one matched what we have in the classroom. So let's see how this goes.